Hello, in this video I'll be going over how to solve basic trigonometric equations. So before we start off this video today, there's certain topics you need to be familiar with before you can even have a go at solving these. Firstly, you need to be familiar with sine and cosine graphs. So this is the cosine graph and the sine graph. So basically this video will be showing how to solve certain equations to find the roots of these graphs. But of course it'll include like certain dilations, etc. So you need to be familiar with these graphs, what they look like and some of their behaviors. You also need to be familiar with these special triangles, specifically the 60-degree triangle with the 30 degrees with root 3, 1, 2, and the 45-degree triangle. So 45, 45, root 2, 1, 1, and these are all 90 degrees. And you need to be familiar with the cast system. So it's like, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So cast is C-A-S-T. This means, the A means all sine, cos, and tan are positive in this quadrant. In quadrant 2, this just means sine is positive. In quadrant 3, this just means tan is positive. And quadrant 4 just means cos is positive. So in quadrant 2, cos and tan are negative. In quadrant 3, sine and cos are negative. And in quadrant 4, tan and sine are negative. So this is the stuff you need to be familiar with before you even have a go at trying to solve these trigonometric equations. You also need to be familiar with radians. So for example, 60 degrees can be written as pi over 3 radians. And 30 degrees is equal to pi over 6 radians. So you need to be familiar with that. Some basic ones you need to be familiar with, basically the unit circle pretty much, and yeah. Basically have a good understanding of these topics before you have a go at these equations. Alright, so now we got that out of the way, let's put up an equation and I will teach you how to solve them. So you'll typically see these equations on a Unit 1 and 2 methods exam or a Unit 2 methods exam and Specialist Maths Unit 1 and 2 exams. And you'll probably need to solve them in Units 3 and 4 with other questions involving calculus. So this is a good skill to know. So our first equation will just be a simple sine equation. So this equation here, we're going to have sine x equals negative root 3 over 2. And we want to find the x values that satisfy this equation between the bounds 0 and 2 pi. So if you're not familiar with this notation here, basically what this means is that x, this symbol here means belong. So if you ever see that, just know that it means belong. So this means x belongs between 0 and 2 pi. It can also be written like this. So 0 greater than or equal x 2 pi. So x has to be between 0 and 2 pi. Right. So we're just taking a look at our equation. We have no numerical value in front of the x here, so we don't need to change this at all. So we can keep that the same. We're basically, first up, we're going to just get x by itself. So what we do is we sine inverse. So x is equal to sine inverse negative root 3 over 2. Now, if you were having a calculator, you could just plug that into your calculator, but I'm going to show you how to do it without a calculator. So what we're going to need is our special triangle. So you need the 60-30 degree triangle. So you have 60 degrees, root 3, 30 degrees, 1, 2. The reason I knew we were going to need this triangle is because we have root 3 and 2, which is specific to this triangle. Because if you drew the 45-degree triangle, you wouldn't have either a root 3 or a 2. You only have 1 and root 2. So that's why we don't need that triangle. Right, so what is sine? Sine is equal to opposite over hypotenuse. So just looking at this here, our opposite is our root 3 and our hypotenuse is root 2. So just looking at this triangle here, opposite, hypotenuse, therefore sine inverse of, let's ignore this negative for now, sine of root 3 over 2 is going to be equal to 60 degrees. Okay? Now, our sine is negative, so let's let's draw a cast symbol up here now. So we have cast. So since we have a negative sign here, it's not going to be in quadrant 1 because sine is positive in there, and it's not going to be in quadrant 2 either because it's negative. So we're basically just going to say sine inverse of negative root 3 over 2 is, instead of positive 60 degrees, it's going to be negative 60 degrees. Because it's going to be like, so I'm just going to draw a sine graph. It's going to be about here, our answer. And if you check on your calculator, you'll find that sine inverse of negative root 3 over 2 is negative 60 degrees. Hopefully that made a bit of sense. If not, I'll probably do a follow-up video on that stuff. So I don't think we needed the cast one really for this specific example, but we'll need it for other ones down the track. So just using your calculator or that method, we know that sine inverse of negative root 3 over 2 is negative 60 degrees. But I'm just going to write it in radians, so it's going to be negative pi over 3. Now, what does this number tell us? So basically what we do now is we've got to draw our sine graph. So just, well, not this graph up here, just the normal graph y equals sine x. We're going to use this graph and apply our translations to it basically. So we'll just draw the graph here and draw on this side here. So this is our x, this is our y, and this is going to be pi, and this is going to be 2 pi. So we only really need to look up until here because our bounds only include 0 to pi. But our first solution is over here. It's at negative pi over 3. So what we do here is we take this difference here, which is alpha, and basically we draw a line from, you see where this circle is right here? Basically we have to draw a straight line because all these solutions on this line here will basically fit our equation up here. So this is what it means. So this straight line, you got to draw a straight line from this initial solution here on the sine graph and apply it all across here. So we can see we have a solution here and a solution here. So what information do we have? We've got a difference of alpha here, which is pi over 3. So our alpha is pi over 3. So if we want to find our solutions up here in the positive region, the difference here is going to be the same difference here and the same difference here. So it's going to be alpha here and alpha here. So sine, so when we go x is equal to our first solution is going to be pi plus pi over 3. So that's going to be our solution here. Sorry, it's getting a bit messy, but you can see that solution. Our second solution is going to be 2 pi minus pi over 3. Simplifying that, we're going to get x is equal to 4 pi over 3 and 5 pi over 3. And that is our two solutions given our bounds for this particular trigonometric equation. Now we can check if this works or not, so I'm just going to rub all this out apart from our solutions, because I know these work, but if you want to double check, you can plug them into your equation and you should get negative root 3 over 2. So if we went sine of 4 pi over 3, putting that into our calculator, so we go sine, make sure you're in radians as well. Radians, sine 4 shift pi over 3 equals negative root 3 over 2. And sine of 5 pi over 3, putting that into our calculator, negative root 3 over 2. Alright, so that's our first equation solved. Let's go on to a different one that's pretty similar to this, but just a tad more complicated. So that's in that equation pretty much. We didn't really deal with any translations. We only dealt really with basically this equation here is pretty much this equation here, sine x plus root 3 over 2. And what we were finding were the x-intercepts. And when we find the x-intercepts, our y value is equal to 0. So if we put 0 sine x plus root 3, we get our equation up there. So that's basically what we were finding, and we were given this domain. So this domain basically says we want, because there's an infinite amount of solutions that can fit it, but we only want the solutions between 0 and 2 pi. Alright, so let's just change this up a bit, and let's add let's add something different to our equation. So instead of that equation, let's have find all solutions that satisfy this trigonometric equation. So I'm just going to write this out. This is b 2x equals negative root 3 over 2, and x belongs between 0 and 2 pi. Right, you can see we've done something completely, it's very similar, but there's one little change. We've put a 2 in here. Basically what that would do, let's say if we had the graph y equals sine x and the graph y equals sine of 2x. So this is y equals sine x. By putting this value in here, you're going to basically, the period distance equals 2 pi over the b value if you're given the form y equals sine x bx. Now our period distance is going to be a lot shorter because we've put a number in here. So for our first equation, our period distance is 2 pi. So one cycle, which is one of these, just goes to 2 pi. This is for the graph y equals sine x. However, for this graph here, our period distance, because we have a 2 there, our period distance is pi. So what does this mean? So this is pi here. That means this entire cycle here is going to happen in here. So basically the whole graph gets squashed by a factor of 2 pretty much. So it decreases it. But the amplitude is still, pretend these are the same height. I just haven't drawn it correctly, but they're actually the same height, except this whole cycle now fits within only pi instead of 2 pi. That's basically what we've done here. So knowing that stuff, we have to change our domain because we're going to get more solutions pretty much. So this is a neat little trick if you're in a methods exam and you're given this dilation and you don't know how to find all the roots. Basically rewrite this so x belongs between 2 pi and 0, but instead of x you've got 2x now, so you need to find the solutions between 2x. So you just times that by 2 to get 2x, and times that by 2 to get 4 pi, and times 0 by 2 and stays as 0. So now you need to find the solutions between these domains, because you're finding for 2x. And once you find these solutions, basically you're going to have to divide by 2 anyways to get x by itself. But we'll see, I'll show you what it means in a sec. Alright, so we know that sine inverse of negative root 3 over 2 is negative 60 degrees, which is equal to negative pi over 3. So drawing our graph, just the normal graph, y equals sine x, we can see our first solution. That's a really poor curve here. Our first solution is here. So we have all these solutions here. And this is pi, this is 2 pi. Now we need to draw all this out to pi over 4. Solution here, 3 pi, 4 pi. Right, we can see we've got a lot more solutions than last time because we've dilated it by a factor of 2. So our first solution is, well, outside our domain, it's pi over 3 here. So our alpha value is just this absolute number. So alpha is pi over 3. So applying that, you need to go from only these numbers here, the whole pi numbers. You'll see what I mean when we do the cos graphs. But you need to do the difference from these numbers here. So alpha there, alpha there, alpha there, and alpha there. So therefore 2x is equal to pi plus pi over 3, and it's also equal to 2 pi minus pi over 3, and it's equal to 3 pi plus pi over 3. And I'm just gonna move this because I'm running out of room down here. And it's also equal to 4 pi minus pi over 3. So therefore 2x equals 4 pi over 3, 5 pi over 3, 10 pi over 3, and 11 pi over 3. Now, you're going to have to understand why I increased our domain values, because we're going to divide by 2 now. So all these numbers are going to get halved. So divide by 2 over here just to get x. So x is equal to 4 pi over 6, 5 pi over 6, 10 pi over 6, and 11 pi over 6. And these are all the solutions to this trigonometric equation. Hopefully that makes a bit of sense. We're going to do another example, except instead of using a sine graph, we're going to use a cos graph. So I'm just going to rub this all out now. They like applying these basically all we've been finding is the roots to these graphs. I've just been putting them in a different form. But it's the same process. If you got given a normal graph, y equals sine x plus something, and you were asked to find the roots. Basically, what I've given you is, I've given you a graph where I've set the y equal to 0, and I've asked you basically just to solve for x. So, you might see it normally in a method exam, y equals sine 2x plus root 3 over 2. And that's like our baseline value of the curve. That's how much it goes up or down. Anyway, let's go into our third example. If you want to have a go at these, feel free to pause the video as well. So this is our third example. Solve this trigonometric equation for the given bound here. Oh, that's a terrible. X belongs between 0 and 2 pi. Alright, feel free to pause the video if you want to have a go. Right, so this one's a bit different from last time, so I've put this number here instead of moving it over there at the start. So what I'm just going to do, just to clean this up, I'm just going to divide by 2, and I'll put that over there. So cos of 2x equals negative a half, pretty much. Alright, cool. Hopefully we're good with that. We also need to change our domain, so x belongs between 2 pi and 0, but we are looking at, it's been dilated by a factor of 2, so we need to look between, well, 2x belongs between 4 pi and 0. So if you don't know what I just did there, instead of looking between x, we've got 2x here, so I've multiplied everything by 2, so we have to look for all our solutions are actually between these bounds here, because we're going to divide by 2 later. Alright, so now we're going to do cos inverse negative a half. You can use your calculator, or you could use the special triangles that I'm going to show you how to do right now. So we're going to need our 60 and our 30 degree triangle, 60 degrees, 30 degrees, root 3, 1, 2, this is 9 degrees. cos theta is equal to adjacent over hypotenuse. So looking at our half, so 1 is our adjacent and 2 is our hypotenuse. So that's our hypotenuse and that's our adjacent. Therefore our angle we need is 60 degrees. So just looking at the positive value now, so cos inverse of a half is equal to 60 degrees. However, we've got negative a half. Now what's that going to be equal to? So this is where we're going to need our cast. So we'll have our coordinates here. So we have cast. Right. So our cos value is negative. That means it cannot be in this quadrant or this quadrant. But it's going to have like an angle of 60 degrees. So you're moving across two quadrants. So to find the angle here, you need to do 60 degrees plus pretty much 90 degrees. Oh, actually no, it will be in quadrant 2. What am I talking about? So it's going to be in quadrant 2. So you're going to have a 60 degree here, but it's not going to be in this quadrant. So you need to add a whole 90 degrees. So it's going to be over here. So the 60 degrees is going to be here. So the actual angle is going to be 120 because this whole straight line is 180. So I have 120. So cos inverse of a half is 60 degrees. However, it's not in quadrant 1. That would only be true if it was in quadrant 1. But it's in quadrant 2, so therefore it has to be 120. Because cos of 60 is the same as cos of 60. And no, hold on. Never mind. So it's going to be 120 because it's in quadrant 2. So 120. Easiest way to do it is though with the calculator. This is just for a more in-depth understanding. Alright, so we got that now. So just to convert 120 to radians, you need to times by pi and divide by 180, and you'll get 2 pi over 3. So it's equal to 2 pi over 3. Now we've gotten rid of that. If you have access to a calculator in the exam, use that unless you really know what you're doing with the special triangles. Alright, so let's just draw our cos graph now. Goes like this. And these are the roots, pi over 2, 3 pi over 2, pi, 2 pi, 3 pi, 4 pi. Oop. Y and X. Right. So where does 2 pi over 3 land? So this is 90 degrees. And this is 3 pi over 2. This is 270 degrees. So 120 degrees is going to be here. So now we draw a line for our solution. We have a solution there, there, and there. But this one is out of our domain. So we don't have to worry about that one. Okay, so we got to find our difference from these whole numbers here. Don't do it from these ones. Only do it from the whole pi numbers. Otherwise you'll get it wrong. Alright, so what's the difference? So pi minus something alpha is 2 pi over 3. So therefore alpha is pi over 3. Yep. Oh no. Yes, pi over 3. So that's our alpha value. So now we know what that is. We're going to apply it to where. So you have to draw it graphically to know where to put the alphas. So you don't. If you had a pi, you'd put an alpha there. But you wouldn't put one there because that distance is too big to be alpha. And we don't need to look outside there. So we can see we've got 4 solutions. So 2x is going to be equal to 2 pi over 3, and it's going to be equal to pi plus pi over 3. It's also going to be equal to 3 pi minus pi over 3, and 3 pi plus pi over 3. So I'm just going to rewrite this down here. So 2x is equal to 2 pi over 3, pi plus pi over 3, 3 pi over 3 pi minus pi over 3. Yeah, I've run out of room again. Sorry guys. And 3 pi plus pi over 3. Now we're going to divide everything by 2. And our solutions will be x is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And those are solutions to this trigonometric equation. Alright, we're going to try one more now. So I'm just going to rub all this out. We're going back to, we're not going to do any more like dilations. We're going to do some horizontal translations in these equations now. So I'm just going to rub all this out. It's very satisfying rubbing all this out, but really long. With tan, we won't be doing any tan equations in this video. I'm mostly going to focus on sine and cos. So mostly today, I think I'm just going to do one more sine one, because sines are the easiest to understand. Alright, if my computer loads. Alright, last one, D. Solve this trigonometric equation. Equals -1/2, and x belongs between 0 and 2 pi. Cool. Righto. So as you can see, this equation is a bit different from the previous ones. In fact, it doesn't have a dilation here, but it's got a horizontal translation here. But we can apply the same rules pretty much. So x belongs between 2 pi and 0. So x plus pi over 3 is equal to 2 pi plus pi over 3 and pi over 3. So that's our new domain. Sine inverse of -1/2. Hold up, my computer's not loading. Sorry. Sorry guys, bear with me. So just using a calculator, sine inverse -1/2 is going to be negative. Oh my god, this computer is not working that well. -pi over 6, just using our calculator. So sine inverse. I just gotta be patient, sorry. So there's going to be -pi over 6 using the calculator, just sine inverse of -1/2 up here. So just drawing our sine graph, which goes through here. Our first solution. So that's pi, and that's 2 pi. So our first solution is going to be here. So we'll have 2 there. And this is going to be pi over 6 in this direction. This is the negative direction because we're over the y-axis. So our alpha value is equal to pi over 6. Therefore alpha from here and alpha from here. So x equals, x plus pi over 3 is equal to pi plus pi over 6 and 2 pi minus pi over 6. So simplifying that, we have x plus pi over 3 is equal to 7 pi over 6 plus, not plus, and 11 pi over 6. So x is equal to 7 pi over 6 minus pi over 3 and 11 pi over 6 minus pi over 3. So therefore x is equal to 5 pi over 6 and 3 pi over 2. Oh, whoops, it's not loading again. Sorry. It's because this computer is not that great for recording and writing on, because it's not that strong. So these are our final solutions. Alright, thank you so much for watching. I'll be doing more videos pretty much very soon. Thank you, bye.